So we have a small little detour into the assignments. So I thought maybe I'd take this opportunity to go over the 6 assignments and show you what you need. And then we'll start in with the next concept that we're going to talk about today, which is going to be inheritance. And I'll show you some inheritance related stuff along with property and synthesize to show you how that works as well. So let me take a look at the assignments. This is assignment number 1. And once you see the assignment, some of you will be relieved because you won't need a full Xcode and iOS for this. It is strictly just Objective-C programming. And most of the assignments are strictly just Objective-C programming. So this is assignment number 1 you're looking at. And how does this become bigger? Let's see. Make this a little bit bigger. There we go. So let me just make this a little bit bigger. There we go. So most of the assignments have multiple parts to them. You can write this in a notepad. You can write this in a text editor. You don't need Xcode for this. And you can load this through a GCC compiler. Or you can do them in an Xcode project, your choice. So you can't get your Xcode to work. You can't get your VirtualBox to work. No problem. You can hopefully get something that takes on a GCC GNU step compiler that works. You can do this by a command line. You don't want to do it on a command line, you can do it through GUI if you want. But most likely, most people, even if you have Xcode, are going to do it with a command line. What are you going to do? You're going to do both parts, and you can put both parts into one program, or you can put them in separate programs. The purpose of the first assignment is to have you practice just traditional programming, creating some objects. So we're going to look at the concept of conditional logic. So conditional logic is used for your application. What is that? If, then, else, conditions. To make decisions during the application lifetime. Objective-C is quite effective this way. And what you're going to do is you're going to have choices between two different things. So it's quite typical in other languages, the syntax and the structure of conditional logic. Through things get more complicated when you determine if 2 objects are the same. So we can have object-based, and as object-based objects are equal. So we're going to see if 2 objects are equal. In Java, it's is an instance of is used. We have a similar technique, actually, Objective-C. So sometimes some of the assignments are more scavenger hunt based, where you're going to need to find the technique or find the method or find the object property or something to do something with it. That's where those books are going to come in handy as well. So you can create a new Xcode project. Now again, if you don't have Xcode, you're not going to be able to create a new Xcode project. You can simply use a command line tool or a command line file. You're going to send me the .h and the .m files. That's what you're going to do. You're going to zip them together. If you're using Xcode, you can just zip the file project, the whole project together, and send me the project. So you're going to create a new project. You're going to use at least one case of each of the following. It's going to be an if statement using the equals operator. If this one's equal to that one to do a comparison. An if statement that uses an is equal to method to see if one is equal to another. And you're going to use compound logic with the ands or the ors. And you're going to perform a logical test to see if something is not true versus is true. This is part 1 that is looking at conditional logic as a concept. Notice I did not give you the theme of the project. That theme is your own. Come up with your own concept. Come up with your own check. Come up with your own thing. So for the person who asked me earlier, how do I know if you did? Not everybody in this room is going to come up with the same theme. Unless you all think alike, you're not going to write the same program. But you're going to use these language constructs in your program. So one of them you can do like a check to see if one time is bigger than another time. Is one thing smaller than another thing? You have choices. If you want to do this in an iOS app, you can do it in an iOS app. What you're going to do is kind of like what we do with the Fahrenheit to Celsius. You can press a button. Is this object bigger than that object? Or is this number bigger than that number or something? And put number A, number B. Press a button. Kind of does the evaluation for you. I'm looking for this syntax here. Don't like GUI, don't like iOS, don't worry about it. Just do a command line thing. Create 2 objects, or create 2 instances of objects, or create 2 numbers or something, 2 strings. say, is this string equal to that string? Something like that. You're doing a conditional logic. If, then, else. If this and this are equal, then do that. Print, one's bigger than the other to the screen. So you're practicing conditional logic, and just remember this is the theme. So put it into anything you want, application theme-wise. This is what I shouldn't call this the theme. This is what you're demonstrating. In part 2, and you can put this together all in one program. You don't have to write 2 separate programs. In part 2, you got methods and parameters. So methods are functions, so you're going to create some functions, and they're defined within a class in order to have, these are the properties. This is a get name, set name. These are methods to change data that's in the class. We looked at methods already. Often these take in I variables, I bars, and the properties of the object, and sometimes the tasks require extra information to complete, property tasks or something of that nature. So create a new Xcode project, or use the same one you did in the previous example, or previous part. Use the same project as you created in the first part if you want. Right, so create a custom class that contains at least 3 public methods. And for main, the main method in main.m, create an instance of the class and demonstrate calling the methods. We did that yesterday, actually. Make your own. Don't use yesterday's example. We did this yesterday with the person. We had Bob and Mary. And we had to show a method that was called show something, show info or something. Or show, maybe it was called show. I don't know what it was called, but we ran a method. Do it yourself. These are not complicated programs. These are easy programs, so there's no excuse. I'm not asking you to reinvent the wheel, to do any rocket science here. You're demonstrating what we've already shown you, what I've already shown you in class. So the idea is to show me that you know the concept. Put them all together, create your own theme for the application or for the program or for whatever it is you're putting together. You want to put this in an iOS app, you can. You don't have to. This is not iOS development. This is Objective-C programming. So put it in anything you want, command line or GUI, your choice. But demonstrate these concepts. So run a method. And your methods are always public anyway, so you don't get worried about this public. You might put 3 methods in there. So they can be accessors, modifiers if you want. Or you could just make up some methods, make up a theme of some choice. Any questions on assignment number 1? Pretty easy. It's kind of like the starter. You should be able to do this one after the first weekend. So let's take a look at assignment number 2. Assignment number 2 is working with the concept of multiple objects. So what do we got here? Now I'm going to see, the first one you can probably get away with just creating one object and having some methods of that object, perhaps. The second assignment you can also do after the first weekend. And there's multiple parts. There's 3 parts to this. Complete all 3 parts. So all of the assignments, you complete all the parts. They're just broken out for abstraction to show you the smaller details of each one of the parts. Part A is the date class. So you're going to design a class called date. And the class should store a date with 3 integers for month, day, and year. You can use integers for it. And there should be a number of functions to print the date in the following format. So you have the month, month, day, year. We have December 25th. We have 25th of December. Those are the 3 formats. So you have 3 different methods. So you're going to have an object called date, and you're going to have a driver program. So perform the following input validation. Do not accept values for the day that are greater than 31. No month has more than 31 days in it. Some of them actually have 28. February does, except for leap year or whatever. It's 29. You don't have to put all that logic in there. You can just make it go from 1 to 31. And do not accept values for a month greater than 12 or less than 1. There's no month 0 and there's no month 13. So where are you going to put that? I'd put it in the methods, because you're going to have to make a driver class. So the first one, you could probably put it all into one file. Assignment number 1, you could if you wanted to, you could put it all in one file. Assignment number 2, you're going to break it out into multiple files. You're going to have a date object, you're going to have a main driver object, and you're going to have a couple more objects here as well. And you're going to have to do a little bit of checking. So it's a little bit more complicated, so it'll step up. Still pretty easy for a programming assignment. You put in the methods for printing these or for accepting the new date and the new time, excuse me, the new dates.
So this is which kind of project? Like,
any project you want. It's an Xcode project. You can make a command line, you can make a GUI. You can make it for Mac OS, you can make it for iOS. You have the freedom to do anything you want with it. But it has to be done in Objective-C. So if you don't have a MacBook and you're still working on a Linux platform and you've got the Linux stuff set up, write a command line. Don't bother unless you don't want to. I mean, unless you want to learn it. I mean, unless you want to learn the GUI part of it, you can do this all in command line. So, and you can do this one after the first weekend as well. This one's kind of like the one I showed you with people or person or student. I can't remember which one it was, where we had one object, but now we're going to make multiple objects. So you're going to have one date class. You're also going to have a payroll class. Payroll class. So design a payroll class. It's not related to the date class. This is another class that you're going to use. And the payroll class is, and I'm going to show you as soon as I get done going through the assignments this afternoon. We're going to be looking at adding class objects to a project on a command line. I'm going to do it for a command line actually. Add class objects to a project, and then we're going to inherit classes from another class because the next one's going to be an inheritance assignment that I'm going to show you. So you can probably get through the first 3 after this weekend. Possibly even the 4th, but we'll see in a few minutes. So here we're going to design a payroll class. I'm going to be making classes this afternoon, as I mentioned. Design a payroll class that has data members for an employee's hourly pay rate, and number of hours worked, total pay for the week. Write a program with an array of 7 payroll objects. So you're going to create an array of objects for this. So you're going to have an array of 7 payroll objects. So you have to figure out how to put an object inside of an array. Not too hard, actually. And then the program should ask the user for a number of hours each employee has worked, and then display the amount of gross pay that has been earned. And then perform the following input validation. Don't accept values greater than 60 for the number of hours worked. So employees can only work 60 hours a week. You can't make one work overtime, I guess. Or actually, 60 is pretty much overtime. You don't have to worry about do you have to worry about overtime? No, just hourly rate of pay, total hours worked. So that's a payroll theme. And then the next one is the day of year. The day of year class is assuming that there's 365 days. And you're going to write a class called day of year that takes an integer representing a day, like 45, which is February. How many days are there in January? 31 days in January? Do the math. 45 minus 31. You're in February something, you know. Translate into a string consisting of the month followed by the day of the month. So day 2 would be January 2nd. Day 32 would be February 1st. Day 45 would be February something else. Subtract out 45 from 31. There's 31 days in January. Day 365 would be December 31st, New Year's Eve. It's day 365. If there's 65 days. How does that work when we have leap year and we have extra days in a month? We still have 365 days in a year, though, don't we? Do we have 366 some years?
Yeah,
then we have 366, don't we? That throws everything off. Don't worry about your accuracy. You don't have to count for leap year and all that other stuff. Actually, you can make it so, well, no. You can record how many days there are. There's only 12. You know that there's, don't count for leap year. You don't have to worry about that. So, demonstrate the functionality of all 3 of these classes in 1 or more driver programs. Note that you can use the same driver program to test all parts of the program implementation, and you do not need to create a separate driver program for each one of the steps. You can do them all separately if you want. You guys know what I mean by a driver program? It's main. So, we're going to see many examples this afternoon on this stuff. So, stop me if you have questions. Otherwise, I'm going on to number 3. If There's only 6 of these, don't worry. Let's see. Number 3, so the first 2 you can totally do after this weekend. Number 3, let's see. I think you can do number 3 too. Number 3, we're going to talk about number 3 this afternoon. Actually, maybe, yeah, inheritance. We're talking about this afternoon. So you can probably do number 3 by the end of this weekend as well. So number 3 says create all 3 parts. Again, you can use an Xcode Project command line based, or you can use a GUI. Doesn't matter. Any kind of GUI you want. Doesn't really matter to me. Part number 1, employee and production worker classes. Design a class named employee, and the class should keep track of the following information. Employee's name, number, and hire date. And then write an initializer. So remember the initializers we saw yesterday with person, I think it was, with a name, height, and age, I think we had in there. You can look at the examples in code 1. It's in the first lecture example. So you're going to write an initializer and the appropriate accessors and mutators. Well, those are the modifiers, setters, and getters for the class using the property and the synthesize. I'm going to show you that this afternoon. We saw it yesterday, but I'm going to show you a little bit more this afternoon on this as well. That is, don't create the accessors and the modifiers manually, do them automatically. If you've got Xcode, you need version 4 and above to support that. Version 3, I don't believe, does synthesize and property. So some of the earlier versions of Xcode does not support it, so you're going to want to definitely use a later version if you're using Xcode for it. Can you do this from a command prompt? Interesting question. I'm not really sure if you can do that from a command prompt. So by the time you get to the 3rd assignment, you're going to want Xcode to make your life easier. Which means you have, I don't know, a couple months before you have to buy a computer. Or get a hold of something. And if you want, you can just get one of those little Mac Minis for $200 or $300. Leave it at home. Don't bring it to class with you. It's okay. Not required to have a computer in class. It's helpful, but it's not required. So you can't afford a notebook. So. Anyway, long story short, you're going to write a class named production worker that is derived from the employee class. We're looking at inheritance this afternoon. And the production worker class should have at least 3 data members following the shift, the hourly rate of pay, which is going to be a double. We have an integer for the shift. So we got a production worker who is an employee, then we derived from an employee. And the workday is divided out into 2 shifts. We have day and night, and the shift variables will hold an integer value representing the shift of the employee worker. And the day shift is shift 1, the night shift is shift 2. And write one or more initializers and the appropriate accessors and modifiers using the property and synthesize for the production worker as well. So we're going to use property and synthesize in this particular assignment. Now we have part 2 is the shift supervisor. And the shift supervisor is also an employee, so it's derived from the employee class. And then you're going to add some functionality for the shift supervisor, and you're also going to use property and synthesize for that. And in part number 3, you're going to write a team leader class. And the team leader class is also a production worker. And a production worker is an employee. So team leader is going to be inherited from production worker. Production worker comes from employee. So we're going to go up 3 lines. Not too bad, actually. It's all the same. And you're going to use property and synthesize in this one as well. And then you're going to make some instances of these objects in a main driver program. You can do it graphically. You can just do it on a command line interface. If you do it on a command line interface, then you're going to exercise the methods for, say, created a supervisor. Supervisor is Bob. Created a production worker. Production worker is Larry, and he's 25 years old. And basically just show the information. Create some objects and show the information that's inside of the object. Not an elaborate program. You're just demonstrating that these objects actually work. They're holding data, and you're going to show the data with the objects. And this assignment's all about property and synthesize. which I'm going to talk about very soon, actually. That was number 3. So number 1, number 2, number 3 you can do by the end of this weekend. Let's see, number 4. Number 4 you can do as well. You'll probably finish this whole class in the month of October. Because remember, we're not meeting again until like November something. This is September something, almost the end of September. We only have a week left. You have an entire month. Actually, let's just take a look at the calendar real quick. The calendar is on bhacker.com. If I still have internet access, and I do. So we're in section 3, and we're not meeting again until the end of November. We have 2 months, which means you don't want to wait. So you want to do these between now and November. So, and I'll tell you how far you can probably get, actually. So far we're on the 4th one. There's only 6 total. So, because November and December are pretty close, they're only a month apart. And this is like right next to the holidays. And I seriously doubt you're going to be programming stuff on December 22nd. You know, in fact, all assignments are due on the 19th before this weekend even happens. So on this weekend, we'll be just doing fun stuff. I call it fun. You may not find it fun, but it'll be fun stuff. Yeah. All right. So, what do we got going on for assignment number 4? Assignment number 4 you can do as well. Assignment number 4 is the parking ticket simulator. This one actually would lend itself quite well to a GUI, to an iOS parking simulation game or something, actually. Where, who knows? You got some objects in here. For the assignment, you're going to design a set of classes that work together to simulate a police officer issuing a parking ticket. And the classes should be designed as follows. We got a parked car class. It represents the parked car. So this class should be simulated by a parked car. And the class's responsibilities are to know the car's model, make, model, color, license plate, number of minutes the car has been parked. So you're imagining in the real world you got a parked car. You're going to make an object that simulates the parked car. And then you got the parking meter class that sits next to the parked car, actually. It's the meter. You put money in the meter and you park your car. Actually, this, I've seen this done in a game before. It's actually kind of cool, but probably not going to do it in a game, huh?
It's you want to simulate it like in the real time?
Yeah.
It just accepts the values and all.
You just change the values around and it creates different scenarios.
Oh, nothing like car picture.
No. Actually, the game just has a car sitting next to it. This is actually a real theme for a game. And you have to fill the meter before the car, otherwise the car gets a ticket. And you're trying to minimize.
Values only.
Yeah, it's value based, yeah. There's like a little meter and you got to push a thing up. And you push the thing up and you win points on the meter. And then if the meter runs out and the car's still parked there and the car's sitting there longer than the meter time, then the cop comes by and gives you a ticket. It's like the real world. It's a stupid game, actually, but it's you don't have to make a game. You can just do this on a command line. And actually, you don't even if you didn't do it on a command line, you did it in an app, you don't have to make a game out of it either. But the theme is actually kind of funny because it mimics a real parking. You got a guy, in the game, you got a guy running to go to the meter, and the guy's got to get to the meter. And you're doing stuff to make the guy run faster to get to the meter before the meter runs up for the parking guy. Which is what happens in the real world, actually. Think about it. If you're really stressed and obsessed over parking meters, there's actually an app that you can use that tells you when your meter is running out. There's one in San Francisco, actually, but you have to get to the right meter. You put the money in the meter, and your app keeps track of your meter. So you don't have to remember how much money's in the meter. And you go, where's my meter? Where's my car? And you can tell if you're going to get a ticket or not. So you can go physically run and put money in the meter. So actually, there's an app right now that tells you bus schedules, too. Next bus. Tells you how far, so you can run to the bus stop when you need to catch the bus. And then there's one that tells you, like, for BART, when you're on BART, whatever, how long it's going to take you, how much longer you have to sit there. before you're going to make it to your destination. And then what kind of delays there are in the lineup, so it can tell you what time you're going to arrive. So you can say, hey, you know what? I'm en route. I'm going to be there in 15 minutes. So you know exactly how long it's going to take you. So. Anyway, let's go back to reality here. What are you going to program? You could make this into an elaborate game, or you could just simply do the bare basics. You can make a command line interface. You're going to make a parked car. Then you're going to make a meter object. The parking meter should simulate the parking meter. And to know the number of minutes the parking time has been purchased. And then we have this parking ticket. So, parking ticket simulates the parking ticket. And this is the class's responsibility to report the make, model, and color of the license plate of the illegally parked car. This is the ticket that you get that shows up on the car when you come back after you didn't feed the meter. So, to report the amount of time and the amount of the fine, how much you get charged, and here's how you're going to do it. The fine is $25 for the first hour or part of the first hour that the car is illegally parked. You can come up with your own cost if you want. I don't really care if you use these numbers. And then plus $10 for every additional hour or part of an hour that the car is parked illegally. And then you report the name and the badge number of the officer who issued the ticket. So we have an officer who's going to go up to issue the ticket. And the officer who's issuing the ticket is the parking officer class. So you have another object, parking officer class. And the class should simulate a police officer who is inspecting your parked car. So this responsibility is to know that the police officer's name and badge number of the object that showed up, to examine the parked car and object and the parking meter object, and to determine whether the car's time has expired. You know those meter people that drive around in the little golf carts and stuff, and they go up and they're like, oh. Actually, it makes it easier. There's like a little red thing that pops up on your thing. If they quickly see, do I see red? No red. Oh, there's red! And then some of them actually put like a little boot in your tire. If you've been there longer, because you're going to get your car towed if it's got a boot on it. And then instead of towing your car, they put the boots on now. Can't remove those boots. It's pretty hard to remove the boots. So instead, you got to go over and get it removed by the parking authority. It's cheaper for them than towing your car, actually. Towing cars is pretty expensive. If you get your car towed in San Francisco, it's $300 to $500 for that experience. I've done it before. So, I was like 15 minutes late coming back and the car was towed. And then you got to wait till the next day, and you got to pay overnight fees for the car if you wait till the next day, depending upon if the parking place that they towed your car to. You go in to pay, there's a $300 fine to get your car. There's a $200 fine to the city because they had to tow your car. You got to pay for the towing. You got to pay for the storage, which is totally ridiculous. It's not fun. Don't leave the meter without money in it. Put more money in the meter than you think you need, because it's still cheaper than spending $500 to get your car back. And lo and behold, you can't get it the next day. It's got to go 2 nights. You're looking at $600. It goes up every night the car stays there, because they got to make room for other cars that they're towing in. Big business in towing in San Francisco. Don't park the car illegally either. It'll be towed immediately. Long story short, you're going to write a program that simulates all these little objects. Why are you doing this? Because the theory behind this application that you're writing, and assignment number 4, is you're mimicking the real world. You're creating a real world application that's mimicking this. The learning objective and the goal of this assignment is to simulate the real world in your application, and it's the type of thinking that you're going to need to put into to actually create a real application. Because you're not going to create something as simple as hello world. This is actually pretty simple. But if you can demonstrate that you can understand how to put these pieces together from the real world, represent the real world objects in programming objects, have the objects communicate with each other, have the objects talk back and forth, and orchestrate this entire scenario. You can do it on a command line if you want, no problem. Or you can do it GUI if you want, no problem. But the learning objective here is not to learn how to make a class. You already did that in the first couple of assignments. Now you're making classes, and you're having the classes communicate with each other. And you're mimicking the real world in this scenario. That's part number 1. Part number 2 is a separate theme in itself. Part number 2 is the car instrument simulator. This one you can actually go online and see a bunch of stuff, actually, that apps that are built. I shouldn't say you can't see the source code for it. There's a game I know that does this on the top. The other one down here is kind of like, you know those games you see the instrument panel? You see fuel gauge and you see gas gauge and stuff. This would make itself for a nice GUI. You don't have to. You can do this all command line based as well. If you don't want to do a command line based, you can do a GUI. And you can make a funny little GUI. Actually, I've seen some fun GUIs with this that simulate the concept. What are you looking at? For this assignment, you need to design a set of classes that work together to simulate a car's fuel gauge and odometer. And the classes will be designed as follows. You have a fuel gauge class, which is going to be equivalent to a fuel gauge object. You could do this on an iOS. Actually, it's pretty cool. You want to know the car's current amount of fuel in gallons. You can just put a little number there. Make a digital one if you wanted to. Or you can make one of those little meters, you know, that go back and forth, like a fuel gauge. Get little lights that turn on, change colors when the gas gets low. It's actually kind of fun. Report the car's current amount of fuel in gallons, graphically or textually. Be able to increment the amount of fuel by 1 gallon. Put 5 gallons in, take 5 gallons out. Well, you're going to take gallons out when you step on the gas. You actually use the fuel. The car should hold a maximum of 15 gallons of gas. Be able to decrement and decrease the amount of gas by 1 gallon if the amount of fuel is greater than 0 gallons. If you have 0 gallons of gas in the car, you're not going anywhere. You're going to go call the tow truck, which is actually cheaper than the parking scenario. But not that that's happened to me, but it has. So that you get AAA to come out for free. But they charge like 5 gallons for gas. The price of gas from the AAA people, if it's not included in your thing, that's expensive. Anyway, long story short, you buy the gas from the AAA guy who goes to the gas station and sells it to you as a premium because it's, you know, service. All right, it's like when you return the rental car and you don't fill it up and they put the gas in there for you. It's like twice as much as if you put the gas in there. So, same concept. You don't have to worry about that for this application. This simulates the burning of the fuel of the gas car. Gas goes down when the odometer goes up. If the odometer is at 0, you're not burning any gas. Here's your odometer. So you want a class that simulates the car's odometer. Here's the responsibilities. So you could have a button. Actually, you could put a picture of a gas pedal. Press the gas pedal. Makes the car go faster. Makes the odometer go up. Makes the gas go down. It's actually kind of fun. If you get into it, it's actually kind of fun. You don't have to. Let's see. Know the car's current mileage. How many miles have you gone? Report the car's current mileage. To be able to increment the current mileage by 1. So when you press on it, it goes 1, 2, 3, 4, 5, 6, 7, 8. We're going faster now. Miles per gallon. And then the maximum mileage the odometer can store is 9,999. No, actually that's larger than that. Almost 1 million miles. Anyway, put a cap on the miles, and then start them all over again. Actually, odometers have a cap on them as well. Not too hard to do. When the amount is exceeded, the odometer resets itself back to 0, which is what happens in real cars too. Now they made it higher though, because cars used to go 100,000 miles and then they reset. Now they go 200. Then they switched it to 200,000 miles. Now it's like 400,000 or 500,000 miles. So you can get a car that says 230,000 miles on it or something like that. Imagine how much the repair bills would cost on that car, though. Anyway, that's a different app. So be able to work with the fuel gauge object. All the components are working together, by the way. it should decrease the fuel gauge object's currently amount of fuel by 1 gallon for every 24 miles traveled. And I don't really care if you use 24. You can make it a hybrid and make it more fuel efficient. Make it burn 1 gallon, gets 30 miles per gallon, 24 miles per gallon. 24 is not too good, actually. That's a gas guzzler. You can make it get like 35 or 40 miles per gallon if you want. So if you push your finger on the gas pedal too much, and it goes up to 40, oh, 1 gallon of gas gone. 80, oh, another gallon of gas gone. And I've done 80 miles. So the odometer goes up to 80. The gas goes down by 2 gallons if you have 40. And this is just a mechanism for controlling it. So you have all 3 parts working together. You could do a GUI, you could do a command line. Simulate it by command. By putting, the user put 5 gallons of gas in the car. And then the user stepped on the gas for 10 miles. And you send 10. And then that is a half a tank. We're not up to a gallon yet, so no decrement on the gas yet. And then it gets up to 40. Oh, lost 1 gallon of gas. So you don't have to worry about the in-between stages. It doesn't happen like that in the real world. You know, we burn in sections of gas mileage per, anyway. But the gauge actually is kind of funny. If you look at your gauge, you know, depending upon the car, sometimes the gauge moves from full tank to quarter tank and half a tank. Newer cars do that, and then in the old days they used to have like more of a faster, like a smoother kind of movement. Now you get in the car, it's at 0. How did that happen? It's because the last time you drove it didn't get adjusted. So, long story short, adjust it any way you want. Demonstrate the class by creating an instance of each one of these little objects and simulate it by filling up the car with some fuel. Run a loop. Put a loop. If you were going to do this with a command line based, you could just run a loop. Now, for I is equal to 0, I is equal to 999,000 miles, and run the whole thing through. You're going to run out of gas before you have to fill it up by the time you get to that many miles. During each loop iteration, print out the car's current mileage and the amount of fuel that's available. You can do it graphically if you want. Be more fun. Kind of interesting, kind of senseless. Probably could turn it into some sort of a game theme in the end, but this isn't a game programming course, so this isn't going to lend itself, well, neither does the parking car simulation, unless you add some joke part of it to it. But long story short, do it any way you want. Implement the different objects working together. A little bit more complicated than the first 3. This is number 4. We only have 2 left, actually. That one's going to be time consuming. Number 4, if you get into it, you make fun of, you know, it might be a little bit more time consuming. You could probably do it after this weekend, though. Oops, I'm sorry. Number 5. Number 5. Number 5, we got ships. Number 5 is easier than number 4, actually. Number 5 is harder to do graphically. Maybe, I don't know, maybe not. Instructions, you got ships, you got a cruise ship, and you got a cargo ship class. So you're going to design a base ship. So number 5 is all about inheritance and cross inheritance because they're all ships. So they can all borrow from ship, but one's a cargo ship, the other one's a cruise ship. So you're going to design a ship, and the ship has the following members to it. So you have one for the name of the ship is a string, for the name of the shop that the ship was built in. The variable of the year that the ship was built, also a string. Could be a number, actually. Doesn't really matter. An initializer and the appropriate accessors and modifiers using any technique that you want. You can use property synthesizer, you can use setters and getters on your own. Do it manually if you want. And a print function. This is polymorphism. This one's a polymorphic. Because we're going to have a print function for all of the ships. You're going to need to overload the print. So this isn't as abstract as the last one. It's a little bit easier in terms of the theme, but it's going to require a little bit more programming technique. So you're going to have a print function that displays the ship's name and the year it was built. And then we're going to design a cruise ship that is derived from ship. And it has the following functions to it. A member function with a maximum number of passengers. So you're not going to repeat any of the ship information. You're just going to add maximum number of passengers that it can hold. Initializers for the number of passengers and mutators. A print method that overrides the print function of the base class. So a little bit more inheritance stuff. You're gonna override it. Excuse me. So it prints out the cruise ship's print function that displays the name and the maximum number of passengers. We probably aren't going to get into overriding, overloading, and hiding, and we're not going to get into polymorphic behavior this weekend. So you might want to wait with this one. It is also number 5. So you might want to wait with it. You could wait for it. You still got a month between the next meeting and the following meeting. If you don't get to it, don't worry about it. You probably could do this one easily in a month's time between the meeting and the due date. So, or otherwise you probably could do it by research and practice on your own. We're not going to get, we'll look at a little bit of overriding, but you're also going to design a cargo ship, and the cargo ship is derived from ship, and the cargo ship should have the following members to it. We got the capacity of tons for the integers, and then the initializer is going to be the appropriate accessor and mutators, setters and getters, any method you want. And another print method that overrides the print function. You probably could do this one. It's not going to be too hard. Demonstrate classes in a program and that has an array of ships. You're going to create another array of ships. And the array elements should be initialized with the addresses of the dynamically allocated ships, cruise ships, and cargo ship objects, and then you're going to demonstrate the print function. So when the derived classes are going to override the base class methods. Not that hard, actually. It's pretty easy. So this one is actually easier than the previous one, abstractly, in concept. You're just practicing some overriding behavior. Print. And then the last assignment is actually kind of easy. It's let me make this oops, what did I do with preview? I think I hosed preview for some reason. Let's just quit preview. There we go. The last one's a piece of cake. Oops. Make this one a little bit bigger. The last one's Gui. It's a piece of cake, but and you're going to need, by this time, you're already into December. Hopefully you have access to a MacBook of some sort for this one. The other ones I could say all the way up through, if you do them all command line, you could probably do them all on a Linux, Unix system with a lot more work than it would be to use Xcode, but you probably can get by. Property and synthesize, I don't know if you need Xcode for it or not. You're going to need the current version or one of the more recent versions of GNU Step for that supports property and synthesize, which hasn't been out since the beginning. It's kind of a newer feature. But what are you going to do? You're going to create a GUI-based application of your choice. And this is an opportunity for you to create your own application that runs on OS X. Do not create an iOS iPad application for a mobile device. This one is based on GUI. I'm going to show you GUI. I'm going to actually write a notepad program for you, show you a couple of different versions of Notepad, show you a tic-tac-toe game. This is OS X, not iOS. If you want to do an iOS, you can do an iOS. If you do something that was not one of my examples, but do something of your own. If you take that option, make sure it's unique. Nothing like what I've shown you in class, and not copied off of the internet. I've seen a lot of code copied off of the internet, actually. And actually, kind of the interesting part now is that in order to get it to work with the current version of, you actually have to convert it. Which means if you give me something that's old, I'm going to know instantly that it's copied, because it won't follow the same signature pattern and the same certificate markings as if it was actually made of the century or made of the current Xcode. Because the current Xcode has got a different way of, the projects themselves, I've noticed, have a sort of a different signature pattern to them. and it's storing the date and the time and everything associated, and well, the old projects do as well, which is, actually, as another point of caution here, I can tell when the projects have been created. So then people are going to pull out their Xcode and they're going to give me just the files without the project. I can still tell by the file. So there's in the header file of some of the information that's kept in the text, we have information that's related to the time and date that the file was created. The Xcode files also have a signature and a certificate to it. So you give me a project that was created, give me an Xcode project that was created, that was zipped up, that was hard, you unzipped it, you loaded it up in your Xcode, you saved it, you said, okay, here it is, Miss Hacker, here you go. I can still go back to the original creation date to know that it was created in 2006 or something. If it was created in 2006, and this is the year 2013, you're going to get 0 credit for it. It needs to be created in this year. It needs to be created during the course of this class, which means open up Xcode, select New Project, create the new project. If you don't create the new project, it's not date stamped. You open up an existing project off of the internet and you use it, or off of one of my examples, you can still go back to the original creation date with the original version. All that stuff's archived in the project files. I know exactly when the example was created. So then the thing is, so students will go, I just borrowed it. It was on the internet. And I just, you know what? I found it. Yeah, okay, it's an old project file. I just loaded it up. But, I did all the coding myself. I created the whole thing myself. No problem. There's a source code repository information that's kept that will tell me what changes you've made in the code. Usually the problem is they've changed the name or they've taken out the name on all of the different files and then they saved it and then they sent it to me. I can tell that you've changed the name. I can actually get back to the original name as well. There's tools that are used to do that, so you can tell. And then embedded in there, there's actually a certificate that says exactly which computer it actually came from. And some people actually sent me files. This happened a couple of years ago, actually. They sent me files that came from a guy who actually had some apps in the App Store that was doing this for a living. He was selling assignments, which was actually kind of funny because it's not a bad idea when you think about it. Long story short, it has this. My Xcode version has a separate signature to it. So do yours, actually. It comes from your keychain. If you haven't noticed, it's marked. It knows what hardware it came from. It knows what computer system and what user and what Apple account and everything. It's all embedded inside of the project, whether you see it or not. Bottom line, don't recycle. You recycle, you get 0 credit. And you recycle and you tell me, oh, I did this and I did that to it. I can tell what you did to it. Which is kind of insulting, actually. But I don't have to tell you this group. But I tell you, about a year ago when I taught this class, about 70% of the class got an F in the class because they all recycled. Because they all didn't want to buy MacBooks. And the biggest excuse was, well, I couldn't get a MacBook. Then if that's the case, put it in a text file that you created on a Ubuntu system or something. Don't put it in, and don't put it in Microsoft Word. I can't compile a Word file or use it in a Word file. So anyway, for the benefit of those people who are going to listen to this video, who aren't, because half the class is missing today, there are ways of cheating, Just pull it out of Xcode, put it in a text file. But if I get something that's in a text file from you, I'm going to look at it with a fine-tooth comb. And then I'm going to run it through my other repository of source code that came out of text files. And it's kind of like turnitin.com. It finds matches and patterns. And it's actually signature patterns that are in the source code. So when you write the source code, some people have a tendency to use certain types of indentations. Some people use certain words or certain formats. Or they combine variable initializations and declarations. Or they have more functions and less functions, and certain data types are repeated over and over again. Formats kind of look the same. There's a signature kind of characteristic to the source code writing, and the program actually kind of finds similar matches with those characteristics, and then I compare it, and if I find anything that matches anything that any other student ever turned in, you're going to get a 0 on the assignments. So long story short, just, I don't really care what you do. Does it work? Doesn't work? I don't care. Just do it yourself. If it represents your own work, you'll probably end up getting 100% for it, even if it's not perfect. If it's your own work. So give me something else, then we're going to go back to the couple semesters ago and half the class, more than half the class got an F. I think only 3 people in one section actually passed. Which is kind of a waste of money if you think about it, because then you got to take the class over again. The cost of the class is more than the cost of a computer. You want anything? I don't know how much the classes are here, but I want to say you could probably buy a computer with that. So you could take your chances and then take the class over again, or you could just get yourself a MacBook, buy the computer, and then do it for yourself. And then you walk away with some skills maybe as well. So, long story short, assignment number 6 is what I was going over. You're creating a GUI. So that's why this came up, because there's tons of app examples all over the place. Write your own project, write your own app, write your own whatever it is you want to do for this. But it is a GUI. So I don't know how you're going to do this one. If most of the plagiarism comes out of this assignment because people don't have Xcode. They don't know how to do it. They can't do it, so they plagiarize it, and then you get in trouble. If you must, don't turn it in. That's better than plagiarizing it. If you can't do it, you don't have a system, you're going to need Xcode on a MacBook to do this assignment. If you can't do it, don't turn it in. Just take a 0. Better than getting an F in the course. Cheaper, too. Because then you got to take the course over again. And then you could just bought the MacBook and did the assignment and not have to take the course over again. So don't turn this one in if you have to plagiarize it. So what are you going to do? You're going to open up Xcode. You're going to make a Gui application out of it. Is it going to be for the OS X or it's going to be for the iOS? You're going to make your own application. And what's it going to do? It's going to use multiple Objective-C classes, and it's going to demonstrate the concept of inheritance as well as other object-oriented concepts presented in this class. It's sort of like the capstone project. It has the same weight. It's assignment number 6. It has the same weight. It's 10 points for each one of these assignments. Same weight as the other assignments. It is worth 10 points, which means if you did 100% on everything in the class, you ended up with a 90. You didn't turn this one in. Maybe you didn't turn that other one in, or one of the other ones. You end up with a B in the class. Not that heartbreaking. You can still pass the class without turning this in. If you have the right equipment, you can actually do this project properly, and you do it, you get the 10 points. This is where you're going to pick up the extra points. So this one's a no-brainer. You're just going to open up, create an Xcode project that has multiple classes in it. I'm going to show you actually when the second weekend. So you might want to wait till the second weekend. Then you'll get tons of examples, because what we're going to do the second weekend is build with multiple classes and multiple interfaces and stuff. And the people with the right equipment will actually have some fun with it, and they'll be able to do some stuff with it. So what you're going to turn in, you're going to compress, and this one I want an Xcode project. This one must be in an Xcode project. So you compress the Xcode project, you give me the Xcode project that has the GUI developed app or the GUI developed Apple OS X program in it that you created on your computer that represents your own work. That's why I say don't turn it in if it's going to be plagiarized. Not going to work. Any questions on the assignments for this course? This is the last assignment. It's not due until December 19th. You have a lot of time to go looking for a system to work with, or ask your friends to borrow a system to work with to create it. I know if you've borrowed a system, it's okay if it doesn't say your name on it, because it's still going to reflect the same century, the same month, same year. It's still going to look current, and it's probably going to hopefully be created in the most current version of Xcode. If it's not, don't worry about it. You can use previous versions of Xcode. If you don't have the current version of Xcode, because you're not going to have it, you can actually get it. I don't know if you can get the older versions. If you don't have Xcode installed on the older operating system, there's no way of installing it now. So, but if you have a friend who took this class a year ago, has a computer, has Xcode installed on it, but it's old, don't worry about it, you can still use it. But when you create the project, it still reflects the current date current year, I can still see that it was created in the century, and it has nothing to do with the comments or the text or anything that you can see in the actual source code. It's embedded inside of the project files. And it's encrypted. You go to change it, your program will not work. You're going to be sending me a program that doesn't work. I'm going to go in and look at it and say, oh, because you modified that file. It disowns it completely. Same thing happens actually if you try to hack code out of the Apple Store, believe it or not. If you find source code for an app that somebody submitted and you modify it slightly, it's all encrypted. It doesn't take the key rights, and it will never run for you. So it's kind of like Apple's way of protecting people. So you can't like decompile an app. You can't decompile apps. You can, but you just can't use them. They won't work. They won't run. Or modify somebody's project. It's from code stealing. They don't want you to steal the stuff. So they encrypt it, and Xcode encrypts it for you, actually. It's already encrypted. Whether it's in the store or not, it's encrypted. So you try to change that encryption, try to fake it, and the whole thing is just garbage. And sometimes it's garbage. It doesn't actually take effect immediately. So you think it's working, and then like a month later or like a week later, it gets craps out on you. Or it prints up a little message that says, "Sorry, this code has been modified. Signature doesn't match, or you're not the owner. You stole this." So the warning in the past used to be kind of threatening. I don't know what it is now. So long story short, don't try it. Just don't turn it in. That's the case. Just don't turn it in. Questions on the assignments for this course now that I've scared everybody? We can go to lunch. All right. So I'm going to end this video.